This video is going through the hydrochloric acid and calcium carbonate homework for year 10. I'm going to read through the questions and give you some pointers. So, question 1. A student investigated the rate of reaction between marble chips and hydrochloric acid. Figure 1 shows the apparatus the students used. So we can see we've got a stop clock, we've got a balance which has got our conical flask on with hydrochloric acid marble chips in, and we can see bubbles of carbon dioxide forming. And there's also this fluffy thing on the top, A. So what is A? We've done this experiment in the classroom. So what did we put on the top of the conical flask? Did we put cotton wool, limestone, polyethylene, or a rubber bung? We're now being given some data. So B, table 1 shows the student's results for one investigation. So we've got time in seconds in the first column and mass loss in grams in the second column. Now we can see both sets of data are numbers, and so we can say our data is quantitative. That means it's numerical, and that means we're going to need to do a line graph. So when they asked us on the next part on figure 2, plot these results on the grid, draw a line of best fit, we need to be plotting data points, not drawing bars, okay? Your data is going to look a little bit like what I've got here. You need to make sure that you are looking very carefully on your scale when you are plotting these. You have half a square allowance, give or take, they let you have. So do count those squares carefully. Now finding your time is quite nice and straightforward, they're labelled out for you. Mass loss, you've got to realise one teeny square is representing 0.1, so we do need to count those up. When you're asked to draw a line of best fit, you're trying to show in science what the general trend of the data, and we can see here we're going to have probably a bit of a curve and it levelling off between 100 and 120 seconds there. So we're looking for one smooth curved line. You then got to use that data to record the mass lost after 0.5 minutes. So have a think, what's half a minute in seconds? And then read that data point off. And the time taken to complete the reaction. So when do you think this reaction is finished? So we're then told the equation for this reaction. So we've got 2HCl aqueous plus CaCO3 solids, that's our marble chips or calcium carbonate, forming CaCl2 aqueous or calcium chloride plus H2O water, which is liquid, plus CO2, which is a gas. That's what that G means. And you're asked to explain why is there a loss in mass in this investigation. So I've put a picture of the reaction. It's not quite in the same form, but why? What is happening that's going to mean the mass drops on our scale? 1E. Another student investigated the rate of reaction. Table 3 shows the results from the different reaction. So we have mass loss when the reaction was complete being 9.85 grams and the time taken to complete the reaction being 2 minutes and 30 seconds. Calculate the mean rate of the reaction using table 3 and the equation. Mean rate of reaction equals mass lost in grams divided by time taken in seconds, and give your answer to 2 decimal place. Now, one of the things you need to keep an eye out for is that the time taken here is in minutes and seconds, so we're going to need to make sure we convert that all to seconds so that we get the right units here. So you're going to take this number, divide it by this number in seconds, and give your answer to 2 decimal places. You're going to lose a mark if you don't do 2 decimal places. You're going to lose a mark if we don't convert to seconds. For part F, we're told the student measured the change in mass of the reactants. Describe another method other than measuring the change in mass of the reaction that the students could have used to find the rate of reaction between marble chips and hydrochloric acid. So they want you to describe a different way to measure rate of reaction, and there are some picture clues on this slide to help you. Finally, for question 1, another student planned to investigate the effect of temperature on the rate of reaction. The student predicted that the rate of reaction would increase as temperature was increased. Give 2 reasons why the student's prediction was correct and tick 2 boxes. So we've got 5 options there and you're going to select 2 of them. Option 1, the particles are more concentrated. 2, the particles have a greater mass. 3, the particles have a larger surface area. 4, the particles have more energy. And 5, the particles move faster. So have a think about that one and choose 2 boxes, please. Question 2 is showing the same reaction in a slightly different way. A student investigates the rate of reaction between calcium carbonate or marble chips and hydrochloric acid. The student used the apparatus shown. So again, we have a conical flask which has got hydrochloric acid in and the marble chips. It's got a bung in the top with a delivery tube where we can see bubbles coming up underneath that measuring cylinder. So we see the gas at the top, carbon dioxide, being collected, and this is all in a water bath, so a trough with water in. The student recorded the volume of gas collected every 5 seconds. They repeated the experiment using hydrochloric acid at different temperatures. The equation for the reaction is calcium carbonate solid plus 2 lots of HCl aqueous or hydrochloric acid forms calcium chloride CaCl2 aqueous plus H2O water liquid plus CO2 gas, carbon dioxide gas. So they've plotted the data for you this time. So A, the student plotted results for the hydrochloric acid at 20 degrees Celsius and 40 degrees Celsius on a graph. And we can see that there. Use the information for figure 2 to answer these questions. State one conclusion the student could make about the effect of temperature on the rate of reaction. So here you want to say something along the lines of increasing the temperature increases the rate of reaction, or does it decrease the rate of reaction, or does it make no difference? You need to decide that. So now you've written your conclusion for part 1, part 2 asks you, give one reason why the student can make this conclusion. So what evidence do you have to make that statement, to back yourself up with? And then part 3, for the hydrochloric acid at 60 degrees Celsius, the student had collected 30 centimetre cubed after 15 seconds. Calculate the average rate of reaction from 0 to 15 seconds. So we need to be thinking about how much gas was collected per second. So you're going to be dividing your volume divided by time for this one.